Hey everyone, this is homework 3.2. I'm going to go through the homework and then I will go back to the classwork. So let's take a look first at this population of ants. They are starting at a value of 10,000 and then it triples each month. So automatically I see the word triples and I know that I'm going to be doing times 3 each month, which means that this is going to be an exponential function because each month I'm going to multiply times 3. So it says complete the table. So we're starting at 10,000. We're going to go to 30,000 then. Then we'll go to 90,000. Then if we triple that, we'll go to 180,000. And then when we triple 180,000 times 3, we will get 540,000. So each month we are multiplying by 3. And as I mentioned today, if you want to find the factor, if you're given a table and you're like, well, what is the factor? Look at two consecutive values and divide. 30,000 divided by 10,000 gives us 3. And in this case, each time we are going up by a different amount, which also shows us that this is not a linear function because linear functions are increasing at the same rate. So we notice that the population differences from month to month are increasing, right? Because we start with a difference of plus 20,000 here, then we go to plus 60,000, then we go to plus 90,000, right? And so the amount is growing each time. Now it says if there are n ants 1 month, how many ants will there be a month later? Well, again, our factor is 3, so if we have 6 ants, for example, the next month we would have 18, so we're doing 3 times n. Now, that is not the same as the equation. This is saying if we have 1 month, a number of, then this would be how many are the next month. But if we want to write an equation, we would use our starting amount times, because we're multiplying, 3 to the nth number of months. All right, a swimming pool contains 500 gallons of water. A hose is turned on and it fills the pool at a rate of 24 gallons per minute. Which expression represents the amount of water in the pool in gallons after 8 minutes? So this would be 500 plus 24 gallons per minute. And so if we're doing it in 8 minutes, this is a linear function. I'm going to be multiplying 24 times m and adding that to our original value, which is 500. So that would be C. The population of a city is 100,000. It doubles each decade for 5 decades. Select all the expressions that represent the population of the city after 5 decades. This is doubling, which means it's going to be exponential. And we're starting at 100,000 and then going to 200,000, going to 400,000. So we have 1, 2, 3. This is our 0th because that's our starting amount. 800,000. All right, so then 4, we're going to be 1,600,000. And then in the 5th year, 3,200,000. Doubling each time, right? And so whatever we choose needs to be equivalent to this here. So 32,000 is too small. 320,000 is also too small. And so when we're looking at this, we're doing it for 5 decades, but we're doubling it. So the factor is times 2. So that helps me to eliminate D because this has a factor of 5. Here, 2 times 2 times 2 times 2 times 2 is the same as 2 to the 5th power. So C and E are our best answers. For number 4, it says the table shows the height in centimeters of water in a swimming pool at different times since the pool started to be filled. Does the height in water increase by the same amount each minute? Explain how you know. So here I'm going plus 0.5. Here I'm going plus 0.5. And then from here to here I'm going plus 0.5. So yes, each time 0.5 centimeters are added. It says, does the height of the water increase by the same factor each minute? So the factor would be what I'm multiplying by. So if I do 150.5 divided by 150, we want to see what we get, and that gives me my factor. So 150.5 divided by 150 gives me a factor of 1.003. Similarly, if I do 151 divided by 150.5, I get 1.00332222. So it changes here. And then if I do 151.5 divided by 151, I get 1.0331122. So in this case, my factor is not the same. No, because this is a linear function. It's increasing by the same amount each time. Therefore, the factor, or what we're multiplying by, is going to be different. Number 5 says bank account C starts with 10 and doubles each week. Bank account D starts with 1,000 and grows by 500 each week. When will account C contain more money than account D? Explain your reasoning. So if I were to start with $10 and then I double each week, I'm going to go to 20, 40, 80, 160, 320, 640, etc., right? If bank account D starts with $1,000 and goes to 1,500, 2,000, 2,500, so far it's still bigger, right? So we would need to think about how long is it going to take to get it to be this large. So this would be 1280. So now we're finally getting into the thousands in 1, 2, 3, 4, 5, 6, week 7. All right. So week 8, we have 1,280 times 2. In week 8, we're now at 2,560. This is still 1, 2, 3. Week 3, we're at 2,500. So we're going to have to keep going a little bit longer before bank account C gets larger than bank account D, because we're starting with such a smaller amount. So at week 9, though, we are going to have $5,120. Well, let's see what we have at week 9 here. So 4, we would have 3,000. 5, we have 3,500. 6, we have 4,000. 7, we have 4,500. Still less than this. So let's see, 8, we get 5,000. And then 9, we have 5,500. So we're still larger at week 9 here, but watch what happens in week 10. When I double that now, I have 10,240. But here in week 10, I'm only adding 500. So now I'm going to have 6,000. So it's in week 10. Now account C is bigger than account D, right? And again, when in doubt, you can make a table to see when this will happen. Number 6 says, suppose C is a rule that takes time as an input, so this is going to be a review, and gives your class on Monday as the output. So for example, at 10:15, you have biology. So write 3 sample input-output pairs for C. So if I do, for example, C of 10:27 equals algebra, right? C of 1 p.m. gives us lunch. You come up with your own. C of blank equals blank. You need to fill in this one on your own. If you write this like this and you don't fill this in, then I know that you weren't listening. You just copied it from the video. So fill that in. You should give me your own example there. It says, does each input to C have exactly 1 output? Yes, because you don't have 2 classes scheduled at the same time. And C is a function because each time has an output of 1 class. All right. Number 7 has the rule that defines the function is x squared plus 1. Complete the table, then sketch the graph of the function. So this is if I put -2 into x, then I get 4 plus 1 is 5. 0 plus 1 is 1. 2 times 2 is 4 plus 1 is 5. 4 times 4 is 16 plus 1 is 17. And you're going to graph that. Again, I'm not going to graph that for you. You can do that. You know how to graph. So you're going to go ahead and graph that on the graph. And if you haven't done it, again, it shows me you're not listening. Today's code word will be Cheeto, since we talked about the inventor of hot Cheetos today, some of us. Okay, so Cheeto is your code word. And I'm going to go back up here and look at this. All right. For some reason, whenever I pause and then come back to the video, it does weird things. Well, whatever. Anyway, so in your classwork today, flow and followers, there's situation 1. A person has 80 followers on social media. The number of followers triples each year. Automatically, we can see this is exponential because it is tripling exponential each year. In situation 2, a tank has 80 gallons of water and is getting filled at a rate of 3 gallons per minute. So this one is times 3, but situation 2 is plus 3 times the number of minutes, right? I shouldn't put 3G. I should probably put 3 times the number of minutes, right? And so we're comparing then this situation 1, which is exponential, with situation 2, which is linear. So for situation 1, the social media, would we use A or D? We would use A because this one represents that each year we're tripling the amount of followers. Whereas situation D shows us that we have 80, gallons of water, and then we're adding 3 gallons per minute after 4 minutes. So this is 80 plus 4 times 3. The next one is looking at the table. So similarly here, the table that shows that is this one here. I'm just going to write B. You don't have to fill in the table here because it's a lot to fill in. So that's this right here, because we see that again, each time we're multiplying by 3 to the next one. This one is letter E. And then the last one that we're filling out would be letters C and F. And so C has 80 plus 3 plus 3 plus 3. And so this is going to be over here in situation 2 because this shows a linear function where we are adding 3 gallons of water every hour. And then this one, F, is 80 times 81 because 3 times 3 times 3 times 3, or 3 to the 4th power, is 81. So 3 to the 4th power equals 81. So this, letter F, is equivalent to letter A. Explain your choices above. Here you're going to explain in words. So A shows a starting of 80 followers, and then times 3 is tripling each year, right? Whereas here, this shows a value of 80 gallons to start and adding 3 gallons every hour for 4 hours. All right. If you want to do the ready for more and you do this and complete it, I will give you plus 5 extra credit points. So that is that. Happy homeworking and see you Monday.